Welcome to the Software Test Professionals Conference Keynote Recording Series. In this video, we will hear from Simon Stewart, the project lead for Selenium, principal engineer at Deliveroo, and the creator of WebDriver, an open-source browser automation framework. Simon will deliver his keynote recorded on April 12, 2018. Release is risky business. Let's join Mike Lyles as he is introducing Simon.
So our keynote speaker for today, if you're in testing and you don't know who Simon Stewart is, I am really surprised. The last conference, we had Jason Huggins, and now we have Simon Stewart, both people who are very influential in building the Selenium project. Simon is a principal engineer at Deliveroo. He's the leader of the Selenium project right now, and he was the guy who gave us WebDriver. And again, I don't think he needs any introduction, but let's give a big hand for Simon Stewart.
Cool. Thank you very much. Good morning, everyone. You need more coffee, right? Everyone needs more coffee. Just give me a couple of seconds here while I plug bits into things and press buttons. You know, I've tried, and it's just easier to get an intern. Okay. Can we get it up on the screen? Ah, fantastic. I've been having a really great conference, by the way. Thank you to everyone who's taken the time to have a conversation with me and talk to me about all the sort of interesting work you're doing, problems you're having, the things you're enjoying, things you're struggling with. Coming to a conference and just meeting everyone is like one of the best bits for me. Like, the talks are really interesting, and that's fantastic, but the personal connections we make are the things that make it really worthwhile for me. So thank you all for being here, and thank you all for your time and patience. Hopefully, at the end of this, you'll walk away with some stuff to think about. You might not agree with all of it, and that's completely fine. So yes, I am Simon Stewart. I am a principal engineer at Deliveroo, and I invented WebDriver. I mean, just stuff, right? And one of the things that happened is I arrived at Deliveroo, and on a second day, my manager sits next to me. And she's a lovely woman and very patient, which is two qualities you need if you're going to try and be my manager. And she goes, "I hear you hate the name quality." It's like, damn right I hate the name quality. Can't stand it. And she goes, "Why?" And I go, "Well, let's take this one back to the beginning. Why do we test software, right? Like, we don't test software for fun. I mean, do we test software for fun? Does anyone like go, you know, I'm going home today and I'm going to see whether I can find that bug in Excel? I have found a bug in Excel before. I wrote a neural network in Excel and then found out that it wasn't giving me the right results, and you never want to do a neural network by hand. We write software, we test software so we don't look like idiots. Right? Nobody wants to push something live into production and then like have no one be able to log in, or not be able to complete an order. For Deliveroo, if we pushed to production and nobody could order food, that would be hilarious, but also deeply unfortunate because that's what we do for a living. So this was the first thing. It's like, why are we even doing this? And it's like, well, we don't want to look like idiots. But the problem is, we have a really serious problem as an industry. And that problem is sort of exemplified by the fact that there's no time for manual testing. Who here feels they have enough time to do all the testing that they want to do before we push a project live? There's like one person who must be really happy about that. It's like, yes! I can relax. So let's go back in the day. I started in IT about 20 years ago. And back in the day, we used to have infrequent, slow releases of software. It wasn't unusual for a project to take a year, sometimes 2 years. 6 months was considered fast. And they were lovely, these slow releases, and things went through the life cycle, and it was great. And then at the end of it, there was time for plenty of manual testing, right? And there used to be huge manual test teams poking away at things, and it was exciting and terrible, and I'd never want to go back to that. And then Agile came along, like big A Agile, and then it became small A Agile, and then it became sort of Agile you can buy from Accenture, which... I remember the first time I was working on a client site once, and Accenture came in, and they sort of put down this massive ring binder, like the one you sort of do keep your records in. I go, what the hell is that? And they go, oh, that's our handbook for Agile. And then I put down like Kent Beck's, programming, extreme programming book, which is like 5 pages long, and I go, that's mine. So Agile led to something really interesting, right? We started picking up the tempo of our releases. Instead of releasing once every 6 months, every year, we were pushing every month, maybe every 2 weeks at the end of the sprint, right? And the problem with this is it reduced the window of time we had for manual testing. But we kind of like having that reassurance, right? We like going click, click, click through the interface, making sure it all works, and then we like having the time to do some of the more exploratory stuff. And so what we did is we went like, well, you know what, having a human being follow a checklist and go like, do this, do this, do this, do this, that's a program. We could automate this, right? And so the rise of Agile led to a push for automation. And that push for automation was so we could bring the testing cycle down and do the same amount of testing in a smaller amount of time. And that's where things like Selenium came from, where we're going, we need to automate a web browser, and we need to test in 5 different browsers, and we need to do X, Y, and Z. And it's like, hang on a second. I have a computer to do this. And the nice thing with computers is, like, they'll do whatever you want them to, whenever you want them to, sometimes in parallel. And, like, I don't know if you're me, but if someone asks me to do more than one thing at a time, I fail miserably. Like, I'm a serious monotasker. I'm incapable of concentrating on more than one thing at once. So if I stop talking as I read my notes, that'll be why. And then Agile sort of continued happening, and it seeped into the way we do things. I guess most of you do something where you claim to be doing some form of Agile, maybe Scrum, that's super popular. Yeah? Are any of you doing like old-fashioned waterfall? Like, who doesn't work in the military? Okay. But now we're looking at continuous delivery. Continuous delivery. That's many releases a day, and there's literally no time for testing. At Deliveroo, like before I came to the talk, it's like fairly sure we push pretty frequently to production. And I asked around some of the engineers, some of the senior engineers who'd been there for a while. It's like, how many times a day do we push? And they went, I don't know, 5, 10. And then I went back over the past week, and we were averaging about 30 deploys a day of our main core application. So, I mean, we're going super fast. If you try and put a human being in that process to do any form of testing, they will be crushed like a bug, or just really tired. So that's cool. So the other interesting thing as well is if you're pushing 30 times a day and you have a test suite that takes 6 hours, you haven't got time to even run all the tests. Right? We're going to have to do something really clever if we're going to continue being able to push quickly. And sort of that's one of the things that I wrestle with, right? I was chatting to my manager. She goes, why don't you like it? And it's like, well, there's literally no time for testing. But we have another problem as well, I said, feigning sadness. The problem is that QA comes too late in the day. Who starts testing a project before they've written a line of code? You do? Fantastic. How many of you wait until a developer finishes a feature and they go like, well, I think it's done, and then they pass it off for testing, and then it gets like done after that, and then you push it live and you get done, and it becomes more and more musical. QA comes too late in the day. Like it tends to be sort of toward the end of the release cycle that we start thinking like, okay, now we've got enough stuff that people can start testing it. But quality is like steak. Do we have any really strong vegans in the audience? Okay, trigger warning. Quality is like steak. Like if you have a steak with sort of lovely lean meat in the middle and a big rind of fat on the outside, you can't cook that. It tastes horrible. Like either the meat is overcooked and the fat is fine, or the fat is cooked fine and the meat is horrible. It's revolting. However, if you have the same amount of red meat and you have the same amount of fat, that fat is marbled through the steak and you cook it. Oh, if you like steak, it's fantastic. And that's what quality should be like. Like we can't bolt quality onto the end of the process. You can't go, okay, I think I'm done with development now. Now let's sprinkle some quality magic on top of it. Quality needs to be sort of thought about all the way through. You know, you can't just put it in as an afterthought. I mean, it would be nice to, right? No? Maybe? I don't know. And I went, my manager was looking like pretty unhappy at this point. But she's a patient lady. And so when I said, there's another problem that we have to deal with, and I don't really know how to tell it. So I blurted it out, because I'm not very good at being subtle. People just don't respect QA, right? I remember when I took my job at Google, I joined as an SCT, and I arrived, and first thing I said to the recruiter was like, this is a poison chalice, isn't it? Joining as an SCT, like no one, and he goes, yeah, no one is going to think you're a proper engineer. It's like, well, I can prove them wrong. Like I was young and stupid. I'm now old and stupid. I intend to remain stupid for as long as I live. It's going to be a lot of fun. I arrived on my first project, and I went, oh, thank God you're here. I went, oh, this is an unusual reaction. They went, you can start writing our tests. It's like, what? And I went, yeah. I mean, you're not good enough to be an engineer. Otherwise, you'd be an engineer. But you're good enough to write tests. You're like the junior member of the team, right? In the hierarchy of software development, you have the architect here, and you have like the manual tester down here. And that's crazy, right? That's absolutely crazy. Like, how many of you work in companies where the test team is larger than the development team? Literally no one raises their hand, right? Thank you, Leo. Leo trolls helpfully from the back. Nobody works in a company where testers outnumber developers. And yet somehow, testers are meant to check everything that the developers do and more, right? I mean, they've got to be superhuman to do this. And the only way they can do that is if they have a whole range of skills that other developers don't need. You need to be able to explain to people why quality is an important thing. You need to be able to explain to people how they can modify their code to do things. You need to have a view of the system that they don't have that goes, hang on a second, I have a holistic view of the system and these are how the pieces fit together. You need to be concerned about this. You need to have great people skills, because nobody likes being told their software sucks, right? You need all these things. These are like tech lead level skills. To be a really effective tester in a company, you need to be like one of the most senior people in the room, because you've got to try and drag a large number of people along behind you. I mean, if it wasn't like that, if the tech leads and the senior people were the ones that had to do like the most work, then, you know, it would be crazy, right? You want to be able to leverage and use that expertise. And so testers are now not seen as allies. They're not seen as people who are here to help us do really useful software and write the best thing. They're seen as a roadblock. Oh, I've done the development, it's in testing. Got to wait until testing is over before it can be released. Like, how many times have you heard that story? Every day, right? Every day. And it's so frustrating. Like, you're not trying to stop something getting to release. It's just that the arseholes haven't done any work up front. And so now you have to fill in all the back bits. You know, it's just terrible, right? And testing shouldn't be seen as a roadblock, but it's seen as a roadblock because we've got this sort of this old-fashioned mindset, right? That, you know, we need to be doing this sort of the manual stuff and things like that. And so, you know, let's strip it all the way back. Let's think about why we do this, right? Testing is about quality, right? That's if a piece of software is well tested, we think of it as being, at least on the surface to a user, high quality, right? they look at it and go like, well, this appears to function. I can log in. I can order food. I can, I don't know, pay someone. I can do all these things, and it doesn't fail. I mean, that's the very definition of quality. A low-quality bridge is one that falls down. High-quality bridge doesn't matter how it's built, but you can drive across it safely. But what's another way of thinking about this? Quality is about managed risk, right? We know when we push software live that it's not perfect. We know that there are problems. It's a risk that we're taking, that somebody is going to find a bug in production and someone's going to be woken up as their pager goes off because the site is down or something like that, right? Quality is about managed risk. And that's the way we think about things. Do we need to test this? Well, this is like a super risky thing. I can't remember who did it. Somebody did a talk recently, and they drew like an axis, and they went like areas of churn and areas of importance for the bottom line. And they drew like the quadrant, and they went like top right-hand corner, where there's high churn, and it's also important to the bottom line of the company. That's where you want to focus your limited testing efforts, right? And it was all a conversation about risk. And it's fine to ship something if you go like, you know what, this is going to be okay. Like I worked on a project once, and we were having very serious conversations about like whether we should go live. And this was back in the day where Agile was new. And we had 6 months to finish the project, and we were like 5.5 months in. And they went, how many bugs have we got? I went, we have 6. And they went, do you think we can push with 6 bugs? And it's like 3 of them are about letter spacing. I think we'll be okay. So we pushed it. But it was a conversation about risk, right? And you guys have that, and gals and folks have that conversation about risk all the time, right? Do you ever go like, yep, this product is bug-free, it's fine to ship? Or do you go, you know what, there's some bugs in there, we know they're there, but it's okay, we can push this in front of the world because we're pretty confident that it's going to stay upright sufficiently often for us to do interesting things, and we'll fix it in the next iteration. Yeah, I think that second case is what we do. So we think of ourselves as being testers and part of a quality assurance team, but we're not really in quality assurance. There's nothing about what we do. We're in technical risk mitigation, right? We're here to help companies deal with their technical risk, assess it, and find ways of approaching it. And I always like to say, actually, this is Melissa's talk sort of brought some of the same to me, where she was going, quality engineering is the balance between user advocacy and technical acumen. Within Deliveroo, we think of technical risk mitigation as user-focused goals with developer-focused means, right? We want to have things work properly, and they've got to work for our users. And the only tools that we have that we can bring to bear on that are to talk to our development team, to our SRE teams, to do something in the technical realm. So that's kind of what we do. We call it TRIM because we tried to abbreviate, and TRM sounds terrible, but if you steal the I from risk, it makes a nice word. And the other thing is I'm not as slim as I used to be, so it makes me smile. So, I mean, that raises the question, right? Okay, you're in technical risk mitigation. Can't call yourself risk mitigation because then the lawyers get really unhappy. What is technical risk, right? There's this, yeah, you're mitigating this thing. What is it? A really useful definition that we came up with is anything that might cause user-visible outages, right? And that's kind of interesting, right? Because it makes you ask the question, who is a user? And we always think of immediately the consumers of our websites are our users, right? But it's not just that. Maybe you've got the salespeople, right? And they want to know what their quarterly figures are. They're a user of the system. At Deliveroo, we have restaurants, and they need to be able to get food. They're users of the system. We have the customer experience people sort of manning the phones so that when something goes wrong and they need to speak to a human, those people need to be able to go into the system and find out all sorts of information about the orders. So they're users as well. So a user is just someone who consumes something, some aspect of your application. So what we do really isn't quality assurance, it's mitigating technical risk. So how do we go about implementing trim? Like, these are the things that we're doing at Deliveroo. You might end up doing something different. The thing that makes our work quite interesting is that a lot of our stuff is on the web, and we can iterate super, super fast. Obviously, you might want to be a bit more cautious if you're pushing apps to mobile phones, right? Because the next time someone downloads that app might be the last time they download the app. But then that's one of the reasons why Facebook came up with React, right? Facebook, we used to push 3 times a day when I was there. When I arrived, they pushed once a day. And then, like, the people in London were going, like, I'm really unhappy having to be awake at, like, midnight while we do a push. And I went, oh, yeah, that's a good point. And so we did a push in the middle of our day. And then we had folks from Israel join, and there was another engineering office there. And they went, it's a bit rude to make us wait until late in the evening. And it's like, oh, yes, OK. And we moved to 3 releases. I think they now do continuous releases. It can be done. Mobile phones, you just have to be a bit more careful. React was an attempt. Native React was an attempt to deal with that. And you can break it down into 2 kinds of things. There are technical approaches. And obviously, later on, there's going to be non-technical approaches. You know the joke, right? The world is separated into 10 kinds of people. Those who understand binary and those who don't. Oh, the world is also separated into 2 kinds of people. Those who like suspense and... I'll let that one sink in, sorry. So yes, technical approaches. I'm here awake. Try the steak, guys, it's lovely. First thing is, developers need to own the tests. Right? You are moving at breakneck speed. And you haven't got time for somebody else to be responsible for things. Also, crikey. I mean, you know, when does a feature, when do we call it complete, right? It's not complete when the code is finished. It's when a user can use it, right? And a user owns, and a developer owns their feature all the way through to release, and ideally past release. Like at Facebook, if you were doing a feature that was going out on the website, you had to be online when they were doing the push, and you had to verify that your feature worked when it was first pushed and it was being canaried. And then later on, if there was a problem, you were the one that got woken up if there was a problem with that feature. So you made damn sure that that thing was solid. And it's a fallacy to believe that you can just write the code and move on to the next feature, write the code, move on to the next feature, write the code and move on to the next feature, because you're not doing a full cost analysis of how much that feature costs. Right? That feature, to get it into production, now needs another human being to come in and tidy up after you. Like, we're not someone's mother. And there's a cost associated with that, right? Like, the developer has all this context in their head. They know everything there is about the feature, and then somebody else gets this thing that appears in their backlog, and they go like, okay, no, I'll have a look at that, okay. And they read around, and maybe they go and talk to the developer, which is super weird, right? And go like, that thing you wrote, yeah, how do I know it works? It's like, oh, grief. Now, the nice thing here is that somebody with a testing mindset, even if developers are owning the tests themselves, somebody with a testing mindset can come in and go, you know, you really need to think about this. Or here's an edge case you might not be concerned about. Or by the way, you know, have you considered, in the previous 3 releases, we've had a lot of problem in this area, so just be careful here. They can bring that. Yeah, who was it? I was talking to somebody, I think it was you earlier, and they went, oh yeah, sometimes the developers finish the feature and they don't even run the tests. It's like, Nat Price once said, I can write code incredibly quickly, particularly if I don't have to prove it works. You're just getting garbage out of these people. So developer, like, this is a whole shift left, right? It's like, make developers responsible for their own code. More importantly, you're not responsible as a tester for writing the tests. Like, you can help people, but you're not responsible for writing them. The whole concept, like, I worked once with a team, and they were in Romania, and the main body of the work was being done in the UK, and we found a bug, and it's like, what are you going to do now? And they say, well, our responsibility is to keep the test suite green. And it's like, great, are you going to go in and fix the software? Oh, we don't have permission to do that. So they disabled the test. Because their incentive was like, get the test green, right? And they had no means of making the test go green other than going like, well, it's not a problem, is it, if we put our heads in the sand? Speaking of putting our heads in the sand, Staging is a fallacy. It's a land of rainbows and unicorns. It is nothing like production. It's an absolute dumpster fire, if I'm going to be polite about it. How many of you have a shared staging environment between several teams? Most people. Does that staging environment accurately reflect reality and production? Hell no. Okay, so I'm going to push a feature into staging, and what's that going to tell me? Well, it tells me that in a world that doesn't exist, the feature may or may not work. Like that isn't helping anyone, right? It might tell you if there's some sort of catastrophic failure on it coming up, but heavens above, you should have caught that a bit sooner. You don't need to go to staging to find out that it detonates on deployment. Particularly nowadays where you could go to AWS or Heroku or any of the cloud providers and just quickly spin up a service and go like, yep, it appears to work. So staging doesn't help at all. But if you can't test in staging, where are you testing, right? Well, you have to test in production. There's nothing else you can do, realistically. You can test in the developer workstations, and then you have to go to production, right? Staging isn't a thing that helps. It's a false flag that promises a whole bunch of stuff that never really happens. So how do you cope with pushing and testing in production? Well, nowadays, we're kind of lucky in that we seldom have just one machine, right? How many people are using like the cloud for their development? Like AWS, Google Cloud. How many people have more than one server available to them? Any of you doing like microservices or like the super trendy things? I hate microservices with a real passion. It's like people go, because they tend to be a technical solution to a political problem. Right? My teams don't like talking to each other. Okay. Make them talk to each other? Political problem? No. I'll put an RPC boundary arbitrarily in the middle of my code for no readily apparent reason. So, okay, we can do this. We now have the ability to do staged rollouts. You don't need to do a big bang release of everything in one fell swoop, right? And so you Canary. You like spin up one server with the new software. You shadow traffic to it. Maybe put a certain percentage through it, and you watch what happens. And if it looks good, then you roll it out a bit more, and if it continues to look good, you roll it out a bit more, and then suddenly you've done a release by accident. And the other thing that we can do to facilitate that is feature flags. So actually what would happen in lots of companies, I know that they do this at Facebook, they push the entire new application to everything in the fleet, and then they enable feature flags, and then people get like new functionality. There was one famous bug called Release Everything Day. So everything is hidden behind a feature flag, right? And they've got this service called Gatekeeper, which looks at the user and goes like, are they in this sort of group? Should they get this feature? Should they not? And it just returns a Boolean, like super fast. So you can have an if statement, which is your feature flag. And one day, this Gatekeeper service failed, and it failed open. So we go like, yep, this user is definitely in this group. And so all the features that were under development, like all the half-written things, were suddenly launched. And there was a sort of moment of panic, and oh, crap. And they rolled back to the previous release. But feature flags are a really nice way of protecting work, right? And it means that you can ship to production without having the feature be complete. You can hide that feature. You can turn it off until you're ready to go. So you can start putting bits and pieces into prod, and when you're ready, flip the switch. But how do you watch what the heck is going on in production, right? Has anyone heard of observability? Has anyone heard of logging or monitoring? I'm hoping for a few more hands than that. Okay, good. It's just because we need more coffee, right? And it's like, So observability is like the next generation of this. First reference that I could find is on a blog from Twitter, but Charity Majors and Honeycomb do a lot of work around this as well. So it's composed of four pillars. And the first pillar is monitoring. And that's where we traditionally do things, right? We have alerts, we have systems coming in, and when a system goes down or a certain amount of bandwidth fails or something happens, we get an alert, right? That's monitoring. And monitoring is backed up by alerting. You take a look at all the data coming in, and you wake someone up. You go like, heavens above. It's all gone horribly, horribly wrong. And then when the alerts come in, whoever it is that's on call has to sit there and go like, well, I need to fix it. So they need distributed tracing. They need to be able to follow a request from one end of the system all the way through to the back end and back again in order to debug that problem, because they don't quite know where it is. So if you've got a traditional 3-layer architecture, you're going to need to have a mechanism for being able to go through all of those. And maybe one of the ways you do that is with log analytics. You take a look at the logs, you pull all that data in, things like that. And that's why one of the first steps you do when you're doing observability and you're starting on this path of implementing this mindset, and it's a mindset, is you do structured logging. So your logs contain useful data, like where is this a request from? What time is it? What system is it? You know, who am I executing this particular command on behalf of? Things like that. Lots of fun. But observability, I think, is going to be one of the cool and key tools that we use as we try and figure out what's going on as we push to production. Oh, that was all quite technical. How many of you aren't developers? I'm hoping like some of you like the life that isn't completely technical. So one of the things that testers have, which almost no one else in the company has, is a holistic view of the system. Right? You need, as a good quality tester, to be able to understand how the system as a whole works. I remember when I started at Deliveroo, and I had no idea how things were meant to work, and I was struggling with it. It was like, can someone tell me, like, just follow an order through? So I put the order through on the app, and something happens, and then I get food. Can someone tell me like the flow of control through the company, so I understand what the heck is going on? And they pointed me to one of the testers. And she sat me down and walked me through everything. And she goes, I know this bit, so you go here. This bit's always a little bit weird, so you go here. Like nobody else in the company really has that sort of same holistic oversight. And so that's a really valuable thing to do when you're going there and you're introducing trim. Because you can go in at the beginning of the story, before anything has even been begun, and go, by the way, set some context. This is how the story fits into the system. These are the things that you're going to be interacting with. These are the things that are known to be difficult. These are the things that are known to fail. These are the things that never fail, so you can rely on them. All right? And that kind of means that the tester role in this case is a bit more like a sort of a user-facing BA, right? A business analyst. They're sort of sitting there going like, yes, we're championing, these are the things. But the nice thing is, going back to the steak analogy, we're now starting to marble the fat of testing and quality into the red meat of writing code, right? We're right there at the beginning of the story. Also, like we said at the beginning, user-facing problems, technical focused solutions. We need to identify user-facing metrics. Like ideally, holding a pager should not be a life-changing event. It should not be like having a newborn child, which keeps on waking up every 30 seconds, going like, I need help. And you go, do you? And it goes, no. My boy used to do that all the time. Adorable little tyke. So the user-facing metrics are the things we care about. They're the things that we should be alerting on. Those are the things that we should be waking people up for. You know, we've already discussed who users are, and users aren't necessarily just consumers. They're anyone who interacts with that system and consumes information from it. And again, here, testers are going to be acting more as business analysts, right? They're going to be talking to the business. They're going to be going like, what is it you care about? Like, if this went off and didn't work anymore, how would you feel? Like, when I arrived at Deliveroo, there was no way of figuring out what was going on. And about a week later, one of the data engineering team put up a dashboard, and it just showed the number of orders we have right now in the system, the number of orders we had at the same time last week, and the number of orders we had in the same time the week before, with a metric saying like plus or minus, and letting you know what was going on. And suddenly we had visibility into what was going on in the company, because you could look at that and you can go, hang on a second, this, you know, we appear to be down like 25%. Something has gone wrong somewhere. And in fact, I noticed an outage on the site that way. I was looking at it, and it was like, you're down minus 70. And it's like, I suspect there's something wrong. And none of the alerts had gone off yet. But this user-facing metric, can I order food, was telling us something really important. And those user-facing metrics are super important. And they end up fanning out to technical things. Like it might be the user-facing metric is, can I order food? But the back-end ones might be, are the databases up? Is there sufficient room in the cache? Are response times sufficiently fast? There's going to be all these things, right? So not only you can't just be a business analyst, you also need to have an understanding of the system as a technical beast. Who here has a manual engineering team? I'm going to just assume the answer is no and no one, of slightly over 1,000 people. Wouldn't it be nice though, right? Beta programs. Like one tester who decides that they're going to run a beta program can bring a huge amount of value. Now, the nice thing with the beta program, if you talk to people and go, oh, by the way, you can get the latest version of the application, the newest features, the shiniest things, people go, yes, I want that. And if you go, it comes with some extra risk, and that risk is that occasionally the app is going to not work. You'd be surprised. Loads of people go like, oh, I'm willing to do that. Like, we're all kind of inured to stuff not working these days. We just sort of turn it off and turn it back on again. The classic IT joke, like, how do you fix it? Oh, turn it back on and back off again. So we have beta programs, right? And you introduce this, and suddenly you've got your most committed users poking around on your application, doing all the things they do all the time. So you know that the happy path and the common paths are being super well tested. And that means that when you have some time for a little bit of manual testing, some exploratory testing, you don't need to worry about that stuff. You can go off into the woods a little bit and do interesting stuff. And that's sort of super, super valuable. And it's a great way of forming a connection with your user community. And your user community are the people that are with you, and if they leave, then you haven't really got a product. Now, beta programs are great for consumer apps, right? If you're doing, I was talking to somebody who was working in the lumber industry, like if you've got 3 customers that are massive, maybe a beta program is going to be hard to figure out how to do. But maybe there's a part of the process where you could go, okay, this one we iterate on quickly enough where it's okay to do that. So going back to this conversation about technical risk, every part of the SDLC, software development lifecycle, adds risk. Right? Before we've written anything, before we've even discussed the story, there is 0 risk because it's like, oh, yeah, that's fine. You start writing the story, you're going to start forgetting things. There's going to be edge cases you're not aware of. There's going to be like functionality you'd like to have, but you don't. And so you're already starting to accumulate risk. As your developers write code, what's the metric? It's like 1 bug per 20 or 30 lines of code, right? So every 20 or 30 lines of code, you've introduced the risk of another bug, and then another one. And so we start doing the testing. And then we go, okay, fine, and now we're going to do the integration testing. And that's risky as well, because we've been testing in isolation, and now we're trying to build up the system. We've introduced more tests. And then when we push to production, that is the riskiest place of all, right? Now, you know, Sun Tzu said, like, no plan survives contact with the enemy. No software survives contact with the public. They tend to do interesting things. And so every time you're raising the risk. And testers can help reduce that risk at every single stage. Like that holistic view that testers have of the system allows them to bring to bear their experience at every single point of this process. Right? You can say there when they're writing the story, think about this. You can say there when they're writing the production code, it's like, you need to also be testing that this thing works. You need to be able to prove with confidence that this is okay, because if it isn't, you're going to be the one holding the pager at 3 o'clock in the morning. I'm going to be fine. Thinking about how unhappy paths work, things like that. But there is one weird trick you can follow that will help make risk significantly lower when you push to production. Faster releases reduce risk. If you're pushing once every year, you've got a year's worth of accumulated changes going into production in one go. That's a hell of a lot of changes. That's a hell of a lot of variables that change. Like if you're doing testing, what you'd like to do is change one variable at a time, right, and see the effect that has. If you change everything all at the same time, who knows what caused that problem, right? But if you're pushing 30 times a day, when we find a problem and we spot it in production, we can go, it was fine at 10 o'clock, it's broken at 11 o'clock, somewhere between 10 and 11, we pushed a change. And we can pull the 10 commits from GitHub that tell us, like, hey, look, here it is. And then we can find the problem super fast. And then we can fix it. And then we can push again to production. And again, that's a tiny, tiny set of changes going in. And life is good. So the fewer changes you have going into production, the better, right? And one way to do that is to not write any code, which has a certain appeal to it. But the other one is like, OK, when I accumulate a certain amount of code, I'm just going to push. So what we do is we run all our automated tests. And if our automated tests go green, if our build pipeline goes green, we push. And it happens automatically without human intervention. And if we notice that the entire world is on fire, then we press like the magic button that goes like, stop doing a push right now, and we roll back to something that we know is good. But that's how we push 30 times a day, because it's an entirely automated process. You go through the code review process, you go through the build pipeline. If the build pipeline looks like it's good, why not put it in front of the world? Like, what's the worst thing that's going to happen? We'll find a user-facing metric that starts dropping off. We'll be able to roll back to an old release, and then we can push out a new thing. Or even now, actually, we put more and more stuff behind feature flags. So if we see a user-facing metric going down, we just restore the old behavior. And then we figure out what's going on, and then we carry on. We don't even need to redeploy. It's lovely. So TRIM, technical risk management, mitigation, is something that happens over a product's entire life cycle. Right? It's not just the software development lifecycle. Like, writing the code is really easy. But then once the thing is in production, it's around forever, right? And we need to think about how to look after it, the care and feeding of our applications. Like, code is like a child, right? It doesn't stop at birth. You have to then look after it until it's ready to leave completely. You know, your products are like that. It doesn't stop when you ship. You have to maintain them. And I think Damien yesterday mentioned Ken Beck. Ken Beck is famous for extreme programming, but he does a lot of thinking about stuff, and he's come up with what he calls the 3X model. You know, in the UK, we talk about the 3 R's of education: reading, writing, arithmetic. It's the same kind of sloppy spelling for 3X. It's explore, expand, extract are the 3 phases of a product lifecycle that we consider. So what's explore? Explore is the beginning of a product, right? It's where you don't really know what it is you're doing, and you're exploring the problem space. So you're trying an idea, trying an idea, trying an idea, trying an idea, trying an idea. And at this point, it's low risk. Like, each of these ideas is, you know, a day or two's worth of work. It's pretty cheap to do. You explore the space. You're trying to figure out what it is. And there's high reward. Like, if you find something that sticks, it's like, fantastic, great. But because you want to be able to iterate that quickly, at the beginning of a product's life cycle, actually, you probably want minimal testing. Like, I do TDD quite a lot. And TDD is great if I want a piece of software that I'm going to have to maintain for 5, 10, 15 years. If I'm doing a disposable thing where it's like, I'm just going to get the shape of the problem, I'm going to figure out what it is, I don't bother with tests. Just write the code. It doesn't matter whether it falls over, as long as I can do a traceability and prove the viability of the idea. So when you're in the explore phase, it's super low risk and it's high reward. So don't worry too much about testing. It's you know, not something to be concerned about. Second phase is expand. Hey, I found an idea and I think it's going to work and it's going to be good. And so you start implementing more and more of it. Here, risk is medium. Like, you haven't yet made it business critical. You haven't put a huge amount of weight on it, but more and more people are starting to use it and rely on it. So if a failure happens, there's more risk associated with it, right? And there's medium reward. Like, beforehand, you'd solved a problem that no one had even been aware that they had. Now, you're just maintaining that solution and improving it and refining it and making it better. But you're probably still moving forward pretty quickly. This is a great time to start putting in testing. Like, once you've done the spike, once you've proved out the idea, one of the things I love to do is just throw all the code away. Like, if I try and keep old code, which I've used to spike out an idea around, it's terrible, right? You know, the human appendix is there because we used to eat grass. And that used to be like where we had like the bacteria to consume the foliage we were eating, and now we don't need it. Like, if you were designing the human gut, you wouldn't have an appendix in there anymore, right? In the same way, if you've got code and you're trying to take it from the initial, oh, I just wrote it and it kind of worked and I didn't care about anything, and you try and keep it around, you're going to end up with like a whole load of appendix, like abstractions around there. So this is a great time to start testing. Now that risk is ramping up, you can start doing it. And finally, we reach the extract phase of the product lifecycle. That's where the product is mature, and that's where it's probably on a critical part of people's day-to-day jobs or the company's bottom line, right? So here, we are super high risk. And if it breaks, and if we make changes, those changes are the changes we make probably offer low reward. They're tiny sort of incremental changes that we're adding. We're making things a little bit better. We're moving things forward a little bit. So there's high risk, low reward. This is where your testing better be good, right? This is where you need your observability in place. You need to be thinking about how do we do testing. You need to be thinking about alerting. You need to be aware of what those user-facing metrics are. But I find this a really interesting way of thinking about a product lifecycle, because now it allows me to have a conversation about the risk associated with it and whether I should be spending my efforts and the efforts of my team on improving things. Someone's going like, oh, I don't know whether this is going to work, we're just going to have a play. Well, it's fine, I don't need to worry about it. Someone goes like, I'm planning on changing like a key part of the infrastructure of the company. That's probably like in the extract phase, right? And so you want to sit there and go like, let's be super careful about this and think before we rush in. It's fine to rush in, but at least think. And the other thing as well is this is fractal in nature. So when you've got your product and you're in production and you're generating revenue, somebody might go, hang on a second, they get some insight into the job role or your company or what it is you do, and they go like, I'm going to do some explorations because I think we could do something new, really interesting. And they go all the way back to explore while in the extract phase. And so the sort of deeper in you go, the more fractal it looks. It's brilliant, right? Ken Beck is a clever guy. Wish I was that smart. So, summary time, because I'd like to leave some time for questions at the end. In summary, death to QA. It's an idea whose time was wonderful and magical, and its time is now past. Long live Trim, long live the king. The king is dead, long live the king, right? Technical risk mitigation allows us to start getting involved in the product development and the software lifecycle far earlier, and that allows us to have far more impact, and it also means that your jobs become a bit more interesting. Like, who wants to just automate some tests or click around when you can sit there and do amazing things like think about how people write software? Like, one of the very first things I did arriving at Deliveroo, I wrote a document that limited the choices of languages we could use for products that can cause a Sev 0 or a Sev 1, like the worst form of outage. And the reason for that is it then meant that the SREs, the software reliability engineers, had predictable runtimes that when something went wrong, they knew how to diagnose those problems. There were no unexpected things caused by someone going like, you know what? I'd like to put Erlang into production. Erlang is a fine language, but if you've got nothing else using Erlang, putting your entire company on top of that is a bold move. And that means that sort of risk mitigation, risk management, is a conversation. You can't just lay down a diktat. The way that I came up with that document was by walking around all the teams, seeing what they were doing already, and then putting down a skeleton in place and going, here's what we seem to be doing, here's what we seem to be comfortable with. What do you guys think? And somebody went, you've got a really tough take on JavaScript. And I was like, yep, I think it's garbage. And he goes, well, I love it. And I'm really unhappy about that part of the document. And it's like, well, that's OK. We don't have to agree. And he goes, well, what are you going to do about it? And I went, well, it's a collaborative document, so why don't we sit down and you can write the bit about JavaScript, and I'll put it in. And he goes, what? And we took a conversation, like picking programming languages is one of those conversations that tends to lead to violence and bloodshed. And at Deliveroo, that conversation was very polite, very respectful, and just like the most civil thing I've ever seen in my life. And I remember I kicked off the meeting, the conversation, and the CTO reached out to me. He goes like, I've wanted to have this conversation for a long time, but I'm terrified by it. And then the VP of engineering reached out. He goes like, Simon. I go, what is it? He goes, you're a brave man starting that conversation. And then a week later, it was all done and dusted, and everyone was like, I was expecting that to be a lot worse. And that's because it was a real conversation, right? It wasn't someone trying to be a diktat and coming up from on high. It was because it was like, I'm going to put out a straw man. This appears to be what we're doing. These appear to be the things we're comfortable with. If you're not happy with it, come, let's have a chat. Let's figure out what we can do. And it brought in people from all over the company to work on this. And that's the kind of thing that Trim is doing, right? Where you sit there and you're going like, here's a problem, and I can solve it. And the nice thing is that was involved in the process before people have even started writing code. They're writing design docs, and now they're going like, okay, I'm doing this kind of a system, therefore I'm picking this language. And so we have predictability. We make it easier for people to switch between teams. It's loads and loads of benefits, and it was all one conversation. Risk changes in every stage of the software development lifecycle, from prototype to like the initial working code, to the thing where the developer says it's done, to the thing where you think it's safe to release. All of that stuff, risk changes, and it increases as you get closer to production. But the worst thing about risk as well is that in each stage of the project's lifecycle, there is also risk. And so think about that 3X model. The first point where you're just exploring a space, it's low risk. When your company depends on it, it's high risk, right? So technical risk mitigation and what we do for a living is try and make it safe and comfortable to deploy. We have these user-facing problems, and we are attempting to solve them using technical means. Okay. Thank you all very much for your time. I really appreciate it. I realize there might be questions.
So if you have questions, raise your hand. Come on. Rick.
Why was it called extract, that third phase?
It's to do with value. So when you're exploring the value, you're expanding the value, and you're extracting the value from the thing. Anthony Marcono has written a lot on the Riverglide blog about the 3X stuff, and there's a Facebook group for it as well, if you're interested in it. Like, I think it's a really useful model for thinking about like the life cycle of a product. It doesn't have the end bit, right, which is like the product is now dead. Like, it doesn't have that sort of the end of the sine wave. But I guess 6X is going to be quite hard to come up with the acronyms for.
Thank you, Simon. My question is, so there are fundamentally two parts of this. One is technical, and the other is user, so the business side. So have you thought about naming it like business risk mitigation or something around more towards the business side of this? Because the price is fundamentally that like business side of this. Thank you.
We wrestled with what we were going to call it for a really long time. I think teleology was one name we came up with. If only because nobody knows what that word means, and so you have a conversation about what it is that you do. And the thing that we're trying to do, it definitely is risk-focused, right? Now, the problem is if you talk about financial risk, then that's one thing. If you talk about business risk, there are risks to the business, but actually that isn't the concern of testing. That's why we have a board. That's why we have people doing company strategy, product strategy, and stuff like that. And that's not the level where we want to be engaged at. So what we're trying to do is figure out, like, where can we get engaged with the software development process so that we can bring quality and sort of marble it all the way through. And so in the end, it was like, well, you know, the best kind of risk that we can deal with, that we are in a place to deal with, and that people encounter all the time, and that's closest to the traditional idea of what a QA is technical risk. But it took like loads and loads of meetings. I think we came up with SETI 2 as well as like one of the names. Because, I mean, SETI is a search for extraterrestrial intelligence. There's also site engineering and transformation, I don't know. There's a new acronym, SETI, that's out there, which we already have a SETI team, so we would be SETI too. But that would seem like unfair and confusing. And you said there was a second part to the question.
No, that's what the question.
Okay, good. Okay. Did I answer it?
Yes.
Fantastic. Always good. Are there any other questions? If not, I'm going to be around at least until this afternoon. Feel free to come up to me and either call me a fool and an idiot who doesn't understand what they're talking about, or go, I am going back to my company and we're setting up our own trim team. Where can I get help with that? I'm happy to talk to any and everyone about that stuff. Thank you all very much for your time, and I hope you have a fantastic conference. Thank you.
Thanks for watching this STPCon keynote recording. Please share this recording on Facebook or Twitter with hashtag STPCon. Learn more about the Software Test Professionals Conference and join us in the Washington, D.C. metro area from October 22nd through 25th by visiting stpcon.com.